Hello class, and here we are with another project help video. So this time it's dealing with module 2, change is inevitable. Alright, so it says in this part of the lab we're going to use data for life expectancy at the birth in Tanzania and Chad to create an appropriate model. Alright, so let's see what we have going on here. So they provide this data to us, and we have two countries. We have Tanzania and we have Chad. And another thing we also have are the years in which this data is modeled for. All right, so this is the life expectancy at birth, and we're just observing the change in life expectancy in each of these countries over the course of a few years. So we have 1, 2, 3, 4, 5, 6 years worth of data there. So our first goal is to plot this data on a graph, and let's take a look at the graph, and then we'll come back and look at our data here, and it'll help us kind of fill in what we have with the graph. So if you noticed here, we just have the first quadrant of the graph here, and in the bottom right, we can already see that we have some values that are already preloaded for us. So we have 47 and 48. And again, this is corresponding to the life expectancy at birth. So if we go back to our data, we'll be able to see, okay, at like what values are we needing to kind of plot for our maximums. So it looks like the maximum value we see between these is 57, so around 58. So when we come down here, we can just go ahead and kind of fill in these. So we can have, so it's 47, so this would be like 49. This would be like 50, 51, 52, 53, 54, 55, 56, 57, and 58. So we should be able to encapsulate all of our values here with what we have on the y-axis here. All right. Now on the x-axis is going to be the years, because x values typically represent the independent variable. So we had from 2004 all the way to 2009. All right. Now, they want us to provide a legend for the countries. So maybe what we can do is we can use red circles for Tanzania. I don't think I spelled Tanzania correctly. Nope, Tanzania. So I should erase this. Boop, 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 boop. There we go. And then we can use blue, let's use blue squares for Chad. All right. So now basically we just need to plot this data. So we have Tanzania on the left, so I'll just plot Tanzania first. So in 2004, Tanzania had a life expectancy of 53.6. So if I come down here, 53.6 is going to be somewhere in the middle. So I'm just going to put it right there, 53.5. Then Tanzania moved up to 54.349. So that's in 2005. So 5439 is going to be probably somewhere in here. And again, we won't be super spot on with these, but your best guess is going to be good enough. So then 55.119 for 2006, so that's right in there. Then 55.926, so that's 2007, so we're getting really close to 56. Then we had 56.777 So 56, and then 0.777 is like right in there. And then finally in 2009, they were at 57.6. So 57.6 is like right in here. All right, and this is a line graph, so we can just connect each of the circles together with line segments. And what you're noticing is each year is a steady increase in the life expectancy in Tanzania. All right, so then we can come over here to Chad. Now Chad has a lower life expectancy across the board, but there in 2004 the life expectancy was 48.27. So 48.27 is like right here. Then 2005, that was 48.5. Yeah, so it didn't really increase all of that much. Then in 2006, it's 48.907. So that's like right here. Then in 2007, it's 49.3. In 2008 is 49.8. And then finally in 2009, it's they reached 50, 50.3. So not as sharp of an increase with Chad when compared to Tanzania. And, you know, thinking from a sociological perspective, you have to ask yourself the question, okay, well, how developed is Chad when compared to Tanzania? Like, Tanzania has a thriving tourist industry. And, you know, with tourism comes foreigners, and foreigners comes foreign aid, because if people like to visit there, then people also want to support and see that country grow, so it's safe for tourists to visit. So this is your first goal here, is just to create this plot, and then let's see what we have coming up next in our project. Okay. All right, so it says using 2004 as year one, and they go ahead and give us the y for our y sub 1 as well. It says find the equation of a line by hand using the first and last point that best approximates the data for Tanzania. Your final answer should be in slope-intercept form. All right. They want us to round the numbers in our final equation to the thousandths place, but do not round until the end. All right. You're definitely going to need a calculator here, but you don't want to round until the very end if you can help it. So our first point, and remember your x values are most often going to be time. So 2004 is going to be 1, and then your y is going to be 53.602. And this is coming directly from our data here. If you go back to look at Tanzania's data, so this would be where x is equal to 1, and each of these would be y sub 1s. So then that would make this 2, 3, 4, 5, and then the last year we're going to use is 2009 or 6. So we're definitely going to want this data here. So x equals 6 and y is 57.666. All right, so let's come back down here. Oops, went a little too far. So then that last point is going to be 6 comma 50, was it 57? Gotta scroll back up now. 57.666. Okay. All right, so now we're going to find the slope, aka the rate of change. Now, something that'll help you is to label the second point as point number 2, and then the first point is point number 1, and then it'll help you keep track of what your y sub 2 and x sub 2 and y sub 1 and x sub 1 are. So then y sub 2 is going to be 57.666. Y sub 1 is 53.602. X sub 2 is going to be 6, and x sub 1 is 1. Now, what is 57.666 minus 53.602? We'll type them in our calculator. And I end up with 4.064 divided by 6 minus 1 is 5. All right. Now that's our slope, but we should probably go ahead and divide that out. So 4.064 divided by 5 gives me, and this is my slope, by the way. This gives me a slope of 0.8128. And you got to think about, this is years, or this is as your life expectancy increases over the course of a year. So you're seeing each year the life expectancy of infants increase that much. All right, so now they want us to put this in point slope form. Now you can use either one of these points to develop your point slope formula, but let's go ahead and let's just use the first point and drop this slope into the point slope along with the coordinates from our first point here. So that's going to look like y minus 53.602 equals this slope times x minus 1. Excuse me, sorry about that. So now we just need to distribute this through, and we're going to add 53. Wait, where do they want this in? They want it in slope-intercept form. So we're going to add 53.602 to both sides. So I end up with y equals 0.8128x. That's going to stay the same. Plus 53.602 minus 0.8128. So what's that final equation look like? Let's break out that calculator one more time. So that's going to be 53.602 minus 0.8128. And that gives me 52.7892. Now, this is a model which represents the change in the average rate of change for Tanzania's, or excuse me, the change in life expectancy, or just the life expectancy for Tanzania if you input various years. So if you input 7, that would be predicting the year 2010, which we don't have in our data, and that would allow us to start to, again, predict how what the life expectancy in Tanzania is. All right, so number 3 says, what is the average rate of change for life expectancy at birth for Tanzania, and explains what this means in context of a baby born. All right, so not exactly sure what units they use for life expectancy. Maybe we'll go LE, because they don't really have a, they didn't really give us any units here. So we're just going to say LE is the life expectancy. All right, so the way we'll do it is we'll say the life expectancy is going to be equal to 0.81828, excuse me. 8. And this is going to be this is going to end up being, in fact, we're actually going to bring in Google here and see what are the units for life expectancy. And the units for life expectancy are going to be so it's going to be, the unit of measure is years, but it shouldn't be years per year. The thing about average rate of change is there's going to be something per something else. So maybe we can say, how should we express this? That's interesting. But in any case, this is the life expectancy that we calculated. It is our slope. And maybe we can say change of years per year. Now I'm going to take a look at this when it comes to your numerical check and everything like that. I'll be conscientious of that. But what we're trying to express here is that the life expectancy changes by this much per year. All right, so it's a change in years per year. So it's kind of funky, but it's okay. So what does that mean in context for a baby born? That means, according to our model, every year that Tanzania continues to, I guess, grow, the life expectancy continues to, get higher and higher and higher. All right. What is the y-intercept? So the y-intercept would be 52.7892. And what that represents is, this would represent the starting point for life expectancy. So I know our first year was 2004, but the starting point, according in this model where x is equal to 0, would actually be 2003. So you can think about your model kind of like, okay, this is where we started collecting the data. This is where they were, and every time we have an x increase, it's going to only add to this value. So this is like think about it like the floor, the starting point, or actually the year 2003. Okay, so you can go and check this out and take a look and see how how this is going. Now let's move on to Chad, and let's do a similar thing for Chad. All right, so with Chad, x of 1 was 1, and y of 1 was 48.270. So that's point number 1. Now point number 2 would be at 6, comma, and let's see what the data was for Chad. 50.346. Okay, that's point 2. Now let's go ahead and do the exact same thing we did for Tanzania. So we're going to have y sub 2 here, minus y sub 1, all over 6 minus 1. Bringing out our handy dandy calculator. We're going to take 50.346 and we're going to subtract 48.270. All right, that ends up being 2.076. I'm going to divide that by 5. And what you notice is the life expectancy increase for Chad is half that of Tanzania. So Tanzania already started at a much higher level, well, relatively to our graph, what it looks like, a higher year, and then it also increases by twice as much as Chad. Let's see, they want it in slope-intercept form, so we can use the point slope form to get this. We're just going to use that first point for data. Oops, x minus 1, there we go. We distribute through here. I'm going to add 48.270 to both sides. What do I end up with? Y equals 0.4152 plus 48.270 minus 0.4152. And this is going to be equal to, so we have y equals 0.4152x. And by the way, there's an x here. And plus, let's break our calculator out. That's going to be 48. It's going to be 48.270 minus 0.4152. And I end up with 47854. Hold up. Kind of running off the page here. And they want it in thousandths. So 47.8548. Now thousandths though, so this is 10 hundredths thousandths. We should round to the third decimal place for both of these. So let's get a final one up here. Y is equal to 0.415x plus 47.855. And this model is a life expectancy for Chad. What's the rate of change? The rate of change is 0.415. And, we talked about that, that funky unit. And this, you interpret the life expectancy the same for Chad as you would for Tanzania. Although they're different, you have a y-intercept of 47.855. And again, this is a starting point for your data. And it also represents the year 2003. All right, let's see. Now, a lot of the stuff we've already kind of talked about life expectancy and how developing countries have a higher life expectancy due to foreign aid, due to a thriving infrastructure. There's a lot of sociological things you can contribute to or attribute to the life expectancy being higher in one over the other. And I look forward to hearing what your answers are there. Let's see, did we miss something up here? No, they didn't ask us to do that for that one. But for Chad, they want us to kind of go back in time a little bit and use our equation to find the life expectancy for a child born in 2001. Now, let's think about it from a perspective. 2004 was 1. 2003 is 0. 2002 would be -1. So 2001 would be x equals -2. So we can take our equation here. And I'm actually just going to copy and paste mine just to make it pretty straightforward. Take that equation, we're going to copy and paste it down here. Oh, word. This might not work out that well. Let's see. Come on, you can do it. There we go. So now I have my equation. And I can plug in x equals -2. So y equals 0.415 times -2 plus 47.855. Breaking out my calculator here. Let's see what we have going on. Typing this into the calculator. We have 0.415 times -2 plus 47.855. What I end up with is 47.025. Now we can go back to the website and compare this. I'm gonna let you do that. So let me know if you have any questions about part 1 of our Module 2 project.